This is building with security first on the SmartThings platform. So I believe strongly in the law of 2 feet. So if this is our agenda, at any point, if we've diverged from what you need, feel free to find another session, check out the booths, whatever you feel like. No one will care. It's all right. So we'll go through who I am. We'll talk a little bit about the device considerations, UI, integration, and then apps. So I'm Jeff Beck. I'm based in Minneapolis, Minnesota. I've been working at SmartThings and IoT for the last 4 years. And you can find me on Twitter or GitHub at BeckJ01. I'm pretty good about responding on Twitter if you have questions or want to chat about security stuff. It's a great way to reach out to me. Otherwise, there's lots of open source on GitHub you can chat with me with. So what are the big considerations we need as device manufacturers? What do we need to think about first? So this whole section's all for your device makers. If you're making an actual device, what do you need to know when you're connecting to the SmartThings cloud to build a secure, good device? And this is where we're going to talk about device identity. We have the idea of the Work with SmartThings program has different levels of trust in our security certification for devices that connect directly to the cloud. And we'll talk about that and what that means for hardware root of trust, device integrity, and protected storage. You have to, at the beginning of every device, know what device is what. When you manufacture the device, you need to care which device is which. So that's like a unique identifier of the device. And the reason you have to think about this in the beginning is this means it's going to be part of your manufacturing process. It needs to be something you design into it. If you are going to be a Works with SmartThings certified device, you have to use either X509 or the validation signatures and serial numbers, because I cannot say that number quickly. I'm sure there's people in here that can, not me. So we have a number of certification levels for devices. And these are all, if you are a direct to the cloud device, so went and got the SmartThings device kit, and you're connecting directly to our cloud, there's 3 levels of certification. Level 1 is this low-level certification. Any data you're doing is non-sensitive. It's annoying, but not immediately noticeable if something goes wrong. The idea of this is something that's passive to your environment sensing, something that is maybe a temperature sensor or something like that. So that is something that doesn't need a very high level of security because it doesn't really affect the environment. Our level 2 certification is in the middle, it's medium. The data is moderately sensitive but non-regulated. So as long as you're not in a regulated environment at all, it's not sensitive, great, that's fine. And then impact would be moderately noticeable. So light control, like if you're making a connected light, that's something that while it's not that sensitive that whether or not someone's light's on, it is much more noticeable if something's not working. So we care about protecting that device a lot more because the impact is a little greater on our consumers. And then level 3 is going to be our highest level of certification, and it has, if you have PII, if you have regulated or security-focused devices. So examples of this is things like video cameras. So not regulated heavily, it's not PII, but it's very, very sensitive because you don't want someone's video camera being hijacked, leaking data, things like that. So that's where if you're building a device that has video, you're going to want to think about getting our level 3 certification. And then with that, we can kind of go through what's required for these different levels. So device identity that we talked about briefly is required for every level of certification. Hardware root of trust is only required for level 2 and level 3 certification. But this is something that you have to build into your design of your physical device. You have to take this into account because it's going on the chip, it's in the hardware. Since you have the bootloader implemented in the ROM, this is something you need to begin with right away and say, how am I going to incorporate this into my design? You're not going to come on and say, okay, I got a manufactured device. How do I make this level 3 secure? Like a month away from launch. It's just not going to work. So thinking about this way up front allows you to actually implement it. There we go. I don't know why I'm pointing at the TV. That has nothing to do with that. Okay. Device integrity, protection, and detection. So you must do something no matter what level you are, but how you actually go about doing it is dependent on which level of certification. So if you are level 2 and 3, you're once again going to trust that hardware root of trust. And secure updates is a must-have. So one of the things that you hear about all the time is IoT devices not being updated. You hear about this general problem of old firmware and security holes not being patched. No matter what level of certification you have to have updates. And you have to have a way of making sure the updates are secure. So from the beginning of your product, your device, make sure you have an upgrade path. Because no matter how good you intend your security, there's always a need to update. There's always a need to improve and secure things. So building that in right at the beginning is important. And once again, if you're level 2 or 3, these updates are going to end up having to use your hardware root of trust, which means it really needs to be tied in from the beginning design. So protective storage is, for levels 1 and 2, you can use your software encryption, no problem. But if you're storing actually very sensitive data, that's PII, things like that, the request is to have it encrypted with hardware. And so testing that, building that out, you're of course going to want to build this in from the beginning. So overview for the device makers. Plan certification early, know what certification level you're going to target when you're designing your device. You want to plan for hardware solutions. You got to plan for updates. I'm just going to hammer planning for updates over and over till you're all bored because updates. Okay. And working through security manufacturing, because if you're talking about device identity and hardware root of trust, all of this requires something to happen at manufacture time. So that means you need to have that as part of your plan. So SmartThings Device Kit. It provides your device identity for you. It provides the hardware root of trust. And if you haven't seen the sessions about it today, if you haven't already seen the booth, there's a booth directly across from us. Basically go out, walk all the way over to the SmartThings area, find the booth, talk to them about it. Figure out how that's going to be. They're going to be here till 6, they told me. So you have a little time. I had a note to remind everyone. They'll be here till 6. Make sure if you haven't seen the SmartThings Device Kit, go talk to them. Next, UI considerations. So this section is all about UI considerations for device makers, app makers, and service makers. So any of these, you really want to start thinking through up front. Who can access this UI and where is the UI? So is this UI on a private device, public? Is it voice operated? If it is voice operated, is it anonymous access? So some voice systems will know who is talking and some don't. So that changes the dynamic of when you're designing your product, what kind of things you want to expose over security. And so knowing these things up front helps you think through it. And is the UI easily manipulated? So And I'm saying user interface. So if you have an IR receiver, can I just go buy a really cheap IR blaster and send commands from outside the house or from a less secure location? And if I can, that's okay. Maybe that's a trade-off you can make, but don't tie it to the locks maybe, or don't tie it to something mission critical. And so you have to make these trade-offs, but you make these trade-offs from the beginning. And then the other thing that I always like to think about is if this is a portable device, if it's a portable UI or something, what happens if I leave it at a coffee shop? Like, did I have a UI that had both like an address and the ability to unlock my front door and turn off my alarm that never shuts the screen off, like sitting on the coffee table at my local coffee shop? Like we've designed those because it's like, oh, this would be really efficient and really great for the user. And then you have to think through, okay, maybe it should auto lock if it has been sitting down for a while or things like that. Like, what's that window? The other thing is, where is this UI? Is it on a big screen? We've seen all of these great TV and ambient displays, and I immediately was like, oh, I could put up all these great information about SmartThings and all this, but how long does it stay on that screen? And if it's audio notifications, are they overheard? So the example I wanted to show is this. Imagine I wireframe this up, I put it on my TV, and it never goes away. It just always sits there. And someone walks up to my house and realizes, hey, I peeked in the window, the back door's open, the alarm's off, I'm going around the back. And this is really easy to mitigate by either saying, I'm not going to make a giant display of all my locks in my house that's really easy for my users to put up, or maybe that's a feature you really want to build, but you say it's going to stay up for 5 minutes, and then the screen's going to go dark, or like blur, or you have lots of options depending on what user experience you're going for. But you don't want to really just have this up all the time in your house. Well, I don't. Maybe you do. The other one that I can't really do a visual for is audio. So if we've heard these great audio stories of like intelligent agents saying, oh, hey, unlock my door, or order me a product. Now, if that doesn't have some sort of second factor authentication, if it doesn't have some verification of the user that's doing it, if it's an anonymous voice, I can shout. You have this canonical example of if I put an Alexa near my door and I shout through the door, I can unlock the door potentially if they let you unlock the door from an Alexa skill. So any voice agent, if it has anonymous access and you do, like, Alexa doesn't have that particular problem unless someone wrote a skill that unlocks a door. But if you have any anonymous access in your voice agent, and you can access that voice agent outside of the home, which is pretty surprisingly easy depending on how well your home is built. So I know a couple people in the Minnesota area that they've been able to add things to to-do lists from someone by shouting through the window because they happen to have their window open in the summer and things like that. Now, a way to mitigate that is if you're going to take an action that you deem secure, prompt with the second factor. You could do a push notification to another device. You could make sure there's maybe a presence required. Or you can combine multiple facets from the beginning of your design and say, we're going to have an easy way of validating this is who they say they are, and then here's how we jump in. So that's UIs. Depending if you're building a device or whatever you're making, those are some considerations. If you're making an integration of anything, generally you want to think through the principle of least privilege, and whenever you're an app maker or a service maker, you're going to be interacting with the SmartThings API. So in order to really do that well, we're going to kind of talk through and understand how the SmartThings OAuth scopes work in order to give you the principle of least privilege. So I'm going to read this slide because I think it's important, and I try not to do that, even though I've done it a couple times. Give access to the fewest actions as possible to accomplish the goal. So if you are building a battery monitoring app, you should not have the permission to unlock a door. There's a canonical paper you can go find where that's an example that came up. If all you want to do is integrate with a security system, you would want to grant permissions to a security system to allow them to maybe arm the security system, but not disarm it. So if you're doing something that knows when you leave the house, it's really good to permission things to only be able to arm the security system and never disarm it, and have a more secure device or piece be able to disarm the system. So the SmartThings scopes have been set up to allow for the principle of least privilege. We've made fine-grained scopes that limit access to big areas of the platform, and then scopes within an area actually break down even more what things can do. And you can check out the auth and permissions guide in Developer Workspace, and see a lot of details. But I wanted to kind of show you what they look like. So we have, up here, we have our general format of our scopes. So if you're reading our scopes, this is kind of what they look like. The permissions are going to be what you can do to the entity. The entity type is what it is. Device is kind of the canonical example I like to use. And the ID is which one. So let's lay out a little scenario. Let's have a location that has two devices. One device, 123, is a smart lock, and we have a device 555, which is a temperature sensor. If we are then given these two scopes, this is what it means. And in this case, it's really we're saying you can read both devices, but you can't execute commands. So if you're building an integration that wants to know about these devices, that's great. And remember, your device 123 is actually a door lock. So any integration with these scopes won't be able to unlock or lock the door, but they'll be able to monitor the status of the door. And maybe you've set up an automation that says, hey, if you left your door unlocked for after midnight, I'm going to go ahead and send you a push notification. Like, hey, did you mean to leave your door unlocked? Instead of actively locking it, you're just a passive monitor. So that's something you could build. Now, if we have something like our device is 123 and X device is 123, that app that I just talked about where you're monitoring the state of a lock, you could actually maybe enhance that and say, I'm only going to deal with this one device, but I can now execute commands for that device. So if you've seen the capabilities in SmartThings, we have attributes and we have commands. When we talk about reading is all about dealing with reading the attributes, dealing with the attributes. Execute is all about dealing with the commands. So now that we have the permission to execute commands on device 123, we could, instead of having a passive system that notified the user that you have your door lock unlocked, you could actually lock it for them. So you could say, hey, if they always lock their door at 7 p.m. and they haven't locked it at 8, I'm going to go ahead and lock it. But you are now not able to access device 555 at all. And that's good, because if you're building that door lock, there's no reason you should be reading the temperature sensor data. And that's where the principle of least privilege comes in, and really thinking about that from the beginning of your app design, and what's the least you have to do. What's the least permission you have to do to accomplish your actions? We also have star. So this is the case where we actually want to monitor all of our devices. We want to know what's going on with them, and that's what our device is star. You're saying you're able to read all of the devices. And in this case, we're only able to execute things on the lock. Now, I'm not sure why exactly you would build this permission set, but if you have a very specific use case, you can come out with that. So overall, when you're thinking about any sort of integration, you want to always ask yourself, what do I have to accomplish my goal? And ideally, you don't want to always ask for the star scopes. Because whenever you're asking for star scopes, you're saying, I need access to every one of that entity type. And that shouldn't be your default go-to. Now, it's the easiest thing to do because you're going to say, oh, if I have access to every device to execute commands, I won't need to know which one's which or whatever. But that's over-privileging yourself. That's where you as an integrator want to minimize how much you access. And we have the tools built into the platform to do it. And to be a good steward of the platform, you want to always adhere to them when you can. And then always only ask for the scopes you're actually using. So this is something where the knee-jerk reaction of some developers is always to just check every box, ask for everything possible, ask for the world, and move on. And you don't want to do that because what you're doing is you're giving yourself an opportunity to be a larger attack surface. So if you ask for every scope, you are now a meatier target that someone will look at because, hey, you have this app has access to everything. I should really focus on that particular thing as an attacker. So, app and Lambda considerations. This is for app makers, service makers. If you are building an automation that is endpoint-based or Lambda-based, here's all the things you kind of want to think through. We'll talk about token management, understanding auth errors, and a little bit on the principle of isolation of entities. So I've talked a lot about OAuth tokens and scopes. I just want to give a quick 101 of the two different parts that we're going to talk about for OAuth tokens. We have access tokens and we have refresh tokens. Now, access tokens are shorter lived. They are the thing that actually gives you access to the resources and the APIs. And then we have a refresh token. These are long-lived, and they're actually only used to get new access tokens. So you don't ever use a refresh token against the normal API to make a request. And the two pieces of the token, the idea is the access token is short-lived because you're going to actually pass it over the network a lot because you're going to make lots of calls to the API, and so it's more exposed. And then the idea of the refresh token is it happens very infrequently, and therefore it has less exposure, and that's what you use every so often to get new access tokens. What we have today is when you integrate your app, you're going to get both of those by default, and it's up to you to store them securely and act. So SmartThings tokens today, you have user-based tokens and smart app tokens. User-based tokens are things that the mobile app has. They're restricted to an individual user. We have something called a personal access token. These are intended for a developer audience, so you all. You're able to go and get a long-lived token tied to you to start developing against the APIs, but it's not really intended for a production-grade system. That's really for a developer, and that's where the smart app tokens really come in, because they're going to be installed into automations are actually installed into a location, and so naturally, instead of being tied to a user, they're tied to the location they're installed into. So that's already adhering to the principle of least privilege, because it's going to narrow the scope of what it has access to, and it's just going to keep going from there. So in general, when you're doing token management, when do you want to store the refresh token? Now, if you are building an integration that's going to call into SmartThings on your own, that's when you're going to want to do it. So anytime if you're doing an integration where you have your own UI or something like that, user touches something and you want to call into our APIs, you want to store the refresh token. And if you plan on building that in the future, you want to store a refresh token. Because if you have refresh tokens, you're able to keep that refresh token authorization chain alive. So you're able to keep Like, keep calling us forever as long as you keep it active, unless the user revokes it. And this is where I want to talk a little bit about how we give you tokens. So when you first get installed, you're given an access token and a refresh token. But also, if you set up subscriptions, anytime we call you, we deliver you a token that you can use to call us immediately back. So instead of having to store a refresh token, you can be very reactive and just always call back to us. The other question is, if you have a refresh token, when should you actually do the refresh? There's two main considerations. You can either be proactive or reactive. The reactive route means it's a little simpler to set up, but that means if you make a call and you get an error, an auth error, you're going to go ahead and try to refresh the token at that point. That means your overall latency of calls to us every once in a while will be higher because you're going to have to make that extra, you're going to make a call, it's going to fail, then you're going to refresh and make the call again. Now, for many applications, that's fine. If you can tolerate that little bit of extra latency every so often, that's a much easier system to implement. Proactively, on the other hand, is you will know when those tokens are going to expire, and you can proactively go out and refresh before it expires if you want. But to do that, that's going to be a little more coordination and overhead on your side. So when you're designing your app up front, understanding if you need that really smooth latency, or if you can be reactive and just say, oh, I know if I get certain errors, I'll do that. Speaking of errors, it's really important to understand our auth errors. We have two main ones. If you get a 401 and you have a refresh token, go ahead and refresh right away. What that means is the token that you have is not valid right now. So you can refresh the token and work right away. Excuse me. The other part is, like I said, when we deliver you an event from a subscription, we do deliver you a token. That token only lasts for 5 minutes. So if you are doing exceedingly long computation and then trying to call back with that token, that's going to be a problem. So if you're delivered a token and you're getting a 401 back, I would actually start looking to see if you have a performance bug or a design issue where you're not calling back. And this is how you can kind of diagnose like really bad GC pauses or something like. The other thing is, if you get a 403, whatever you just did isn't right. Don't retry. If you're making a standard call and you start getting a 403, like you haven't changed your integration at all, and you start getting a 403 for a certain device you're integrating with, there's a chance that device was then deleted. Because what we're saying is that with a 403 is your token is correct, but you don't have access to the thing you're doing anymore. So either the user removed your access to it, or the device itself is just gone and it's deleted. And that's the more likely case is someone went, or a device is broken and got factory reset or deleted, and you just don't have access to it anymore. If you're doing something completely new, like you push out an app update and you suddenly start getting 403s, you probably don't have the correct scopes. And then the other one that's interesting is if you've added new functionality and you may need new scopes for that, all the old installs of your app aren't going to like naturally have those scopes. So you have to make sure that you can progressively enhance based on the scopes that your app has during that transition period. So, isolation of entities. The idea is when you are acting on data that's coming in, you need to validate that is tied to the right thing. So the idea is if we call you and we give you an event subscription, you need to validate that call came from us. So you need to make sure you understand that the calls coming into you are who they say they are. The other part of this is you need to make sure if you have a device integration or something that a user can't inject someone else's device ID and then try to pass in affect your system. So you need to make sure that if you have a user interface or something like that in your integration, that you've tied these together to do the checks. So if all of our calls out of the SmartThings Cloud into your automations do have HTTP signatures. This is the simple Node.js code to actually do the check, to validate that the calls that you're getting are from the SmartThings Cloud. When you create your application, there's a payload that has the public key, and you're able to then save that and use that to verify everything. You'll note that this is all done inside your app. So signature verification is nice because it doesn't require you to call out somewhere else. So it keeps the latency down. Now, questions? Yes. Oh, they'll come with a mic, so.
So I'm curious about revocation of these certifications. So if a company gets certified by Samsung, and then later they're caught doing something really suspicious, or they go out of business and they can't do updates anymore, what happens to the devices that consumers already have installed in their homes? Does the consumer get a notification saying this is no longer a certified device?
I don't believe we've had the case of someone falling out of certification where we've had to notify, and I don't believe I don't know that we have an official stance yet. AKA, I really hope we never have someone be that bad of an actor. That's something that I think we'll have to look at.
Okay. Yeah, because they can't help it if they go out of business. They're no longer
Exactly.
responsible for maintenance. All right, thank you.
So I was looking and thinking through when you showed the level 1 through level 3 certification slide. Some of those devices that get integrated might require it to be, they might be safety critical. So how do you balance fail secure versus fail safe?
So if you're designing that device and if you're making a safety concern, you always opt for the safe human. Like always fail to a way that's safe for the human. So if it's a safety critical device and you need to fail such that, I'm not sure what case you would fail such that it's more.
And I think an example was the next slide. I think what you showed was locking a door. So if electricity goes out, then if you take the approach to fail secure, you wouldn't be able to unlock that door.
So in that case, you do need to fail. Like, we actually have these electronic locks in our office. We had the power go out, and they fail open because for fire reasons, you have to be able to get out. And that's, if you're building a device, though, when we're talking about security of hijacking it and something like that, you do have to think about if there's a case where it fails and it locks, is that lock in a place where there is still a fire safety door or something like that? So you have to take into context not just, that's part of the install of the device. So if you're installing the device like a lock in a door that is the only fire exit, it has to fail so it opens if you have a fire or something like that. If you have like an emergency exit that has an alarm on it right next to that door though, it can fail locked because you do have a fire exit. And that's where when you're if you're designing and building that device, you need to think through what your potential customer install would look like as well. And I would hope you don't fail such that you lock a bunch of people in a room. we have to think of the human element in that case.
Can I change the capabilities of a device dynamically based on something like time or the user's preferences?
Yes. What it ends up being, though, is the device, like, are you thinking a hardware device or like a software device? Either?
I'm not sure. Potentially, like maybe my I want to integrate my home camera with my lights so that if the lights are off, turn the cameras off too. Maybe that's not the best example.
So
better example. I only want my locks to be unlockable while I'm on vacation because I want to be able to let my house sitter in or something.
So that's something you could build with, you could do that with automations, and you could probably, what I would actually do is instead of trying to enforce a rule of what locks and unlocks it, is you want to do something that enforces the state that you want it in. So the idea is that you build something that converges to that state. So if the door gets unlocked physically or whatever, it knows that you're on vacation and it should immediately relock it. So you can build that, and you can think through, if you're building that system, you could ask for functions that are also only ability to lock. Like if I'm building an automation that is going to ensure that things stay locked within a certain period of time, it only needs permissions to lock things. But you could build an automation that did that, but I don't think what it doesn't do is say things can't unlock the door, because the physical device itself still has ways to unlock, like in the case of locks.
Is it okay if I do a follow-up? Oh, okay. So I'm not sure I understand. What I want to be able to do is say, I want to use Samsung's ability to lock down the capability for this device to automatically unlock, except for when I log in and authenticate and say, for this week, I'm going to give you the permission to unlock, because I want to be able to unlock you remotely. But otherwise, I don't trust it with that permission.
Right. That's not something built into the platform today. Like, effectively, it would be like removing or granting permissions to all the applications dynamically, and that's not something the user would have control over today. As an integrator, what you could do is ask for those permissions at certain times, but that's not something in the platform today.
Hi. I have a question related to this level 3 certificate. Does it mean that all the, let's say, cameras that are enabled for the SmartThings have already this level 3 certificates?
No, I was just using cameras as an example of something you'd want to be level 3 certified for works with SmartThings.
Okay, so that depends on the producer, basically, if they go through this process, or how does it look like?
So if they're a device to cloud, a direct device to cloud integration, so this is something that uses all the way direct connect to the cloud. It's not going through a hub or cloud to cloud or anything like that. Then if they want to be works with SmartThings certified, they'd want to build all of the level 3 certification into the product to begin with. But there's not an existing camera, to my knowledge, that is that exact path to the cloud.
Okay, thank you.
You have, okay.
If I make my own application, then I can use OAuth authentication, that is fine. But if I'm developing a service which runs in the cloud, which may have applications or web interface and many other things, its own thing, but I want to make from my cloud service to SmartThings cloud calls, what is the best authentication mechanism you recommend?
So the best authentication mechanism is still going to be OAuth. You're still going to want to, it all depends about how you're installing and connecting between the user. And that's where some of the one-on-one sessions earlier that were recorded and things like that kind of started talking about them. The idea is if you're discovering the install from inside the SmartThings application, you could do an app that's endpoint-based that does OAuth into your system, and now you have kind of a two-way exchange of tokens, and the systems will be able to call into each other. And that's all secure then. And then it's principled per integration.
So OAuth is the mechanism you recommend in any case?
So unless you're doing a device, All of our API integrations are based in OAuth.
Sorry, one
Yeah.
more. So you showed an example of specifying access to a specific device type and a device ID. That one, yeah.
Entity type. So this is devices.
Devices. Okay,
So-
how is the identity assigned to a specific device?
The ID. So the identity is when the device joins the cloud, it gets an identity unless it is a device to cloud. And the devices that go directly to the cloud, actually their identity is baked into the manufacturer. So for those devices, as part of our certification for Works with SmartThings, they get their identity, it's a UUID baked into it. Whereas like a Zigbee or a Z-Wave device, when it's joined to the platform, it gets an identity associated with it.
Okay, I'm satisfied with UUID, but I'm worried about these little integers.
Oh.
Could I keep joining and
That's just so I didn't put
connecting and then roll
UID.
over? Okay, so even on the local network, it is a UUID.
Everything's UUID. I just put that because it doesn't fit on the slide otherwise.
Okay, thank you.
Yeah, otherwise it runs way up. Yeah. There's all of our identifiers are very large and don't really make for great slide content. Well, I'll go all the way to thanks.